All right, guys, Honors Chem, we are going to learn a little bit about our solubility rules today, and I'm going to demo some of these things for you. So today, I've got a bunch of solutions that I've made up, and we're going to look at some of the precipitation reactions that we will see. So this first reaction that I have that I want to do for you, we are looking at lead to nitrate, and we're going to react it with lithium chloride. So I've got a solution of lithium chloride here and a solution of lead to nitrate. So lead to nitrate, lithium chloride, you'll see that they're both colorless and clear. So if I look at this reaction that I have here on the board, I've got the lead to nitrate and the lithium chloride, and I'm predicting, notice that all of these are double replacement reactions. I'm predicting that we're going to make lead to chloride, and we're going to also make 2 lithium nitrates for everything that we've reacted. So I'm going to put, about 10 drops of the lead nitrate in there, and I'm going to put some lithium chloride. Now, using our solubility rules, what would we expect? Would we expect any precipitate before I put in this lithium chloride? What do you think? Okay, I'm going to put it in. Let's see if we get what we expect. Now, that's not such a great reaction, but if you can see, there is a bunch of cloudiness in there. It's not all soluble. There's white little crystals in there. So it's not a great reaction. It's not super colorful, but we do get some cloudiness. So that cloudiness that we see in there, we would expect that to be the lead to chloride, okay? So that would be what we would expect to see there. Let's try another one, okay? So this next one, I want to try some lead-3 chloride, and I'm going to react it with some potassium carbonate, okay? So let me get these open. You'll notice that the lead, or not the lead, but the iron 3 chloride is yellow. It is clear, but it is definitely not colorless. So I'm going to start with about 1 ml of the iron 3, and then the iron 3 chloride, and then I'm going to add some potassium carbonate. Do you think we're going to get any precipitate here? What do you think? Do you see that precipitate? Do you see that kind of rust orange on there? And I'm actually getting some gas too. I'm getting some carbon dioxide coming off of there. Do you guys see that gas going in there? Oh, there we go. That was a good reaction. It's not super warm, and it's a little bit cool, but not super cool. So let's look at that reaction. So we would say that we would produce lead-3 carbonate, but we actually had some gas coming off this. So I'm betting that this lead-3 carbonate decomposes into iron 3 oxide and carbon dioxide. I bet we have this double replacement, and then we have a decomposition going on here. So notice how it's nice and red now? Rust. We made rust, guys. Okay, and we created carbon dioxide. So we definitely get a precipitate, and we actually get a decomposition out of that one. Okay, last but not least, we are going to look at lead nitrate, and we're going to put it with some calcium sulfate and see what we've got. So I've got some calcium sulfate here. You notice that there's stuff on the bottom because calcium sulfate really isn't very soluble. So this is going to be a very not strong solution here. So I'm going to start with some of the lead chloride, or the lead 2 nitrate, colorless and clear. Let's see if we get any precipitate with the lead and the calcium sulfate. Do you see how that turned cloudy? We are definitely getting our precipitate there. Okay, that's another good reaction that turned nice and cloudy. So what we would predict, sulfates are really not soluble. So we would expect that precipitate to be the lead to sulfate there. So we would expect that to be the solid, this to be the solid, and this to be the solids that we've seen. So we can use our solubility rules to predict precipitates that we see. All right, have a great day. We'll see you later. Bye.